As a coder, you need to know how to make a file executable and understand what happens when it is executed. And that is what we exactly want to talk about in this video. To do so, we will get into three main topics. We start by explaining the role of kernel and shell. Then we get into details of file permissions, and we will actually make executable files in practice. And finally, we will get into two types of the executable files, which are binaries and scripts, all with real examples. So let's go. A computer is actually a piece of hardware which is in control of a kind of low-level program, which is actually the instruction about how different parts of hardware should be connected to each other. And this program is actually called kernel in computer science. If you want your computer to show the word hello on the monitor for you, what should you do? You should ask the kernel in binaries, zeros and ones. And that's the problem, because it is so difficult to figure out which exact combination of zeros and ones are needed in each situation we want to ask our computer something. So how can we solve this problem? It turns out that we can have something in the middle here. We can have something that translates a conventional human readable language that we say our request in it into computer readable zeros and ones which computers can understand. And this thing in the middle is called a shell for the kernel. Actually, a shell is a kind of interpreter which translates something like echo hello, which we mean we want hello to be shown on the monitor, into the responsible zeros and ones in order for hello to be shown on the monitor, and it gets those zeros and ones into the kernel for us. And this is what exactly shells do in computer science. In order to figure out the exact role of a shell on real life, let's look at Terminal, which is an application that is widely used by coders. Terminal is an application that is actually so simple. It is a window and a place that we can type things in it. It turns out that Terminal is actually nothing by itself. It doesn't have any brain, and it doesn't know what we mean when we say echo hello. But as soon as we connect our terminal into a shell, we can type that echo hello, and as soon as we hit the enter button on the keyboard, it runs and shows the word hello on the monitor as a response. And it asks for the next command. Here we can type the next command, for example, date, which is responsible for showing us the current date and time. And if we run this, it answers and asks for the next command. And this is exactly what shells do. They listen to our commands, they translate what we mean into responsible binaries into the kernel, and they show us the answer. And this is a kind of cycle which goes on and on and on. So it is important to learn how you should work with shells on your computer. If you work on Windows, you have PowerShell installed by default on your system, which is a window like this. But PowerShell is actually limited to Windows platforms. But there's another shell which is really important, which is Bash. Bash is actually an open source shell which has a big history that we don't want to go to details in this video. But it's really widely used and can be installed on different types of operating systems, from Windows to Mac OS to Linux. And it is a kind of standard in coding and programming world. So it is so important for you to learn Bash, at least. If you want to learn just one shell, it is recommended to be Bash. Although Bash is not installed by default on Windows, you can have it on Windows. Actually, if you go to the Git website by a Windows PC and download the Git installer, Git bash will be also installed alongside Git on your Windows, and this is actually how a Git bash user interface looks like on Windows. However, if you work on recent versions of Mac OS, I think since Catalina, you have ZSH pre-installed on your Mac by default as the default shell. Of course, you have bash also installed, but the default shell is ZSH, which we are going to have a demo on it now. Okay, I'm on a Mac, and there is an application called Terminal, which is installed by default on all Macs, that I want to open. And it is exactly what we talked about it earlier. It is a simple application which is actually a window which doesn't have any brain and doesn't do anything by itself, but it connects to a shell in order to perform the tasks. It actually is connected to ZSH now, as you see the name of ZSH on the top bar of the window here. It means that if I type echo hello as a command, as soon as I hit the return button and run it, it sends the echo hello into ZSH, and ZSH is the interpreter responsible to translate it into zeros and ones. And it sends those zeros and ones into the kernel and shows me the result here. If I type date, I can run it, and ZSH is the shell which is running it for me. If I type echo by, ZSH is the shell that knows what I mean by echo by, and it do it for me. Another thing I can do is changing the shell I'm using. For example, I can go to the bash. That was ZSH, and now I'm using bash. As you see, when we get into bash, two things are changed. First, at the top bar of the window, instead of ZSH, it is written bash. And also, this part here is also changed, which is called prompt. Prompt is actually something that is written at the start of each line, which you can type your command, which is called command line. You know, this line is command line, and the first part of the command lines, which is written by default by your shell, is called prompt. When we were in ZSH, the prompt was the red arrow key and the tilde like this, but when we are in bash, the prompt is something else, which you can see. It is bash -3.2 and a $sign. But important thing is that ZSH and bash are kind of identical in what they do and also the grammar and syntax they use. So if you are using ZSH like me as your default shell on your computer, don't worry, it is the same as bash in whatever we want to do here. So we can do echo hello here also. The result is the same. If we type date, the result is the same. And we can get back into ZSH. So we can easily change the shell we are using in our terminal. You know, Python is also a kind of interpreted language. It means it's like a shell. It has a shell. And I can use it in terminal. If I type Python 3, Python shell is activated in terminal. I can type Python codes here. But it is important to notice that if you change your shell, language is also changing by it. It means that if I type echo hello in Python shell, it doesn't do anything. It doesn't know what I mean by echo. Echo is actually something in the bash language or ZSH. Python doesn't know what echo means. In Python, if you want to show something on the monitor like echo in bash, you should use print. And so I can say print hello like this in Python shell. And if I hit return, it says hello. So, and I can also quit and get back into the ZSH. Let's go to the next part of our video, which is about file permissions. Whenever you create a new file, even when it is completely blank, and you don't store anything on it, it is important to know that there are lots of data attached as metadata to it. And there are lots of parts in metadata. For example, date added, date created, date modified, display name, permissions, file size, creator, or things like that are stored in metadata. And one of the important parts of metadata, which we want to work here, is permissions. In order to have a closer look at metadata, let's go and have a short demo. I want to make a new file and get into its metadata, but before that, let me show you two important things. You know, I'm on a Mac, and here if I go to the Go menu into the computer, I see Apple SSD. Apple SSD is actually responsible for the main storage of my Mac. If I get into it, I'm now in a place where is called root. You know, actually, root is the most basic folder in the file system hierarchy, where everything is stored and started from. And you see 4 folders in my root folder. One of them is users. If I go into users, I see a folder named Reza, which has a symbolic home icon on it. And if I get into it, this folder is actually my home folder. And I can exactly go to my home folder from terminal in command line interface. If I open the terminal application and if I type pwd, which is responsible for print working directory in order to see where I'm actually now in my terminal, it says you are in the Reza folder, which is located in users folder, which itself is located in the root folder. So actually, we are in the home folder here also, in the terminal and also in the graphical finder on the Mac. If I want to see the list of files and folders which are located in the working directory in the terminal, I can type ls, which stands for list. And if I run it, I see a list of folders or files located on my home directory, which, as you see, is the same as what we see here in the graphical interface. So I can go into tmp folder by typing cd change directory, cd tmp. You know, the prompt changes into arrow key tmp, which says the working directory is now tmp. I can clear the screen, the terminal screen, by typing clear and running it. Here I go to the tmp folder in the graphical interface to show you what happens graphically alongside with the command line interface. So I'm in the temp folder both in my command line interface in the terminal and also the graphical user interface. If I type ls, I see the list of the 2 folders I have here, oh my disk and hello. I can make a new directory by mkdir command and the name of it, for example, mkdir test. Eventually, a test folder is made here. Okay, I get into the test folder in the graphical interface, and if I want to go into the test folder in the command line interface, I should type cd test. I'm getting into it. If I type pwd, you see here that it says you are in the test folder, which is located in the temp folder of Reza folder of users folder in the root of your system. So we are in the test folder and I clear this screen. Here I want to make a new file called reza.txt. To do so, I use touch as a command for creating new file. If I type touch reza.txt, a new file with this name will be created. As you see in the graphical interface, the file is created and it is completely blank. Nothing is stored actually here. I can type hi, this is the first file. I can save it, I can close it, and I can access to the content of a file by cat command. If I type cat reza.txt and run it, I see the content. If I make a new file, another new file called test.txt, And if I type cat test.txt, I can see that nothing will be shown to me because nothing is stored here. Even though this test.txt is completely new and completely blank, there are lots of metadata attached to it and stored in it. I can type mdls test.txt. You can see a lot of metadata that is stored here. And I don't want to get into the details of these data here, but I want to say that lots of metadata is stored to any file, whether it is completely blank or it is full of different types of content. So if I clear this screen here, I can type ls. ls, as you know, is a command which shows the list of the files which are in the current directory. And it says we have two files, test.txt, reza.txt. But commands in shells can have different options while running. If I type ls and I want a kind of option to be added to it for running, I should type a dash or a hyphen. And after that, I can type different characters which are responsible for different options. For example, if I type L as an option and I run it, I'm running ls with the option L, which stands for long. It is actually the same ls command, but with a new option which shows some parts of the metadata related to each file which is listed for us. Here it says we have a reza.txt and these are some datas, actually metadatas, about it, and another file named test.txt with these datas. So be careful. Every file has lots of metadata which is not stored as the main parts of the data on it. One of the important parts of the metadata is what you can see here, which is called permissions. Permissions is actually a data attached to each file which defines who can do what to the file. And it actually is made of 9 characters. The first 3 characters are defining what the owner user, the creator user, can do to the file. R means read, W means write, and X means execute. So if it is R and W and X, it means that the user, the owner user, can read and also write and also execute the file. The second 3 characters define the permissions for the group. This part shows that what other users, which are not the owner, but are in the same group, can do to this file, whether they can read, write, or execute. And the last 3 characters show the permissions for other users, which are completely non-related. So let's get into a real-life example. As you saw before, we created 2 files, reza.txt and test.txt, in the test folder. I want also to make a new folder here called, for example, Reza folder. And so there are 3 things in this folder, in this directory. If I type ls, I get the list of these 3 things here. 2 of them are files and 1 of them is actually a directory or folder. But if we type ls with -l option, we get a long list. It means that we can see other kinds of metadata related to each file or folder. As you see here, for example, for Reza folder, the first thing here we can see is D, RWX, R-X, R-X. This is actually the permission part. But what is the D here? D is actually showing that this is not a file, it is actually a directory. So for Reza folder, which is the new folder we have created recently, We see the D here, but for reza.txt and test.txt that are actually files in this directory, we don't see any D, and we see a kind of dash or blank part here. So for example, for test.txt, what we see here, it means that, so it is not a directory, it is a kind of file. And the permission is this. What does it mean? As we said, the first 3 characters show that the owner user can read, write, but not execute the file. Why not execute? Because there is no X here. The next 3, the second 3 characters are R blank blank. It means other users in the same group can only read the file. They cannot write or execute. The last 3 is R blank blank. It means other users can just read. They can't write in it or they can't execute. So no one can execute this file. In order to make this file executable for example, the owner, we should change this permission part. In order to change the permission of a file, we should use chmod. Chmod is actually a command which may stand for changing the mode of a file or something like this. And in order to add the X to be executable with the permission, we should type +X and then the name of the file, which is test.txt. And if I hit return, it doesn't say anything, but actually the permissions should have been changed. In order to see whether it is changed or not, I get another ls-l, and as you see here in the permissions, I see it is rwx. It means the user now can execute. It is r blank x. The group users also can execute, and others also can execute this file. And as you see, the color of the file name is also changed, and it is because of the ZSH that changes the color of executable files for us. So this is actually the first thing you should do whenever you want a file to be executable. But note that instead of using this 9-character pattern, sometimes a numerical pattern is used to define the permissions for a file. The rule is like this. For each part, the user part, group part, and others part, we have 3 characters. Each character can be related to a number. X is always related to 1, W is related to 2, and R is always related to 4. And what we do is that we calculate the sum of these numbers in each part. For example, imagine that permissions of a file is like this. RWX for users, RX for groups, and RX for others. The numerical permission of this file is 4 plus 2 plus 1 for the user part, 4 plus 1 for group part, 4 plus 1 for others part. That is 755. So if you see the permission of a file is 755, don't panic. Let me show it to you. I want to clear this screen here. I want to make a new file. For example, I name it coder. If I ls-l, I see, okay, this is the new file I've created here. The permissions is like this. I can say chmod, and instead of typing +X, I want to say chmod 755 coder. And this command should change the permission to what we have talked about earlier. So if I type ls-l again, I see the coder is in red, which says it is executable, and as you see, it is RWX, RX, and RX, the exact pattern that we were seeking. But the next question is, how exactly can we execute a file? Executing a file in graphical user interface is so simple. You just double click on it and it is executed. In command line interface, for executing a file, you should type dot slash and then the name of a file. For example, if I want to execute the file coder, I should type dot slash coder and return. It executes the coder. Of course, as coder is completely blank and nothing has been stored in it, it doesn't do anything when it is executed. But I want to show that this command is how we execute it. And the important part is that if I say chmod -x coder, as you see in graphical interface, the icon has changed. And if I type ls-l, it is no longer in red and no longer is executable in permissions. And if I type dot slash coder in order to execute it, I get a permission denied error. So you see that if I want a file to be executable, I should change the permission with chmod. I can say chmod and a numerical pattern like 755 or chmod +x and the name of the file. Then, as you see in the graphical interface, it changes, and if I type ls-l, it would be changed. The coder is now executable, and for executing and running the file, I should type dot slash the name of the file. And this is how exactly a file would be executed. Finally, we get into the interesting part of our video, which is making real executable files with real codes. So, you know, executable files are actually divided into two types. One are those executables who contain the zeros and ones, or better say, compiled binaries, responsible for whatever we want. So those binaries can be executed directly and everything gets done. But the other type of executable files are those who do not contain the binaries. They actually contain the human readable codes, like the echo hello code that we saw before, that should be interpreted before execution by the computer. We call these codes actually scripts. Scripts are actually the lines of codes which should be interpreted before execution and are not compiled. So, for example, if we type echo hello in a file and we directly execute it on our computer, nothing happens because our computer doesn't know what echo hello means. Computer needs zeros and ones or binaries. So if we want a script file to be executed, we have to mention the interpreter for it on the header of the file. So the file can be executed using that interpreter or shell on the computer. But the exact way of mentioning an interpreter of a script file when we want to execute it is using a syntax like this: a shebang sign and the location of the interpreter we want to use. And I said shebang. Shebang is this combination of SHA or hash sign and the exclamation mark that you see the description of Wikipedia here in this slide. But this is a kind of sign that shows that this is the location of the interpreter we want the script of the file to be interpreted by before execution. So let's go to an example in real life and type some scripts and binaries and run them in order to see what happens. So I want to open the terminal application. I go to the temp folder, I make a new directory called hello exec. I go into the hello exec folder and I want to open the VS Code, which is the code editor I want to use in order to write a C file. Here So I make a hello.c file. I type a kind of code in C language. I type include stdio.h. I type int main, and for example printf hello and a \n, and I return a 0, and that's it. It is a simple C code. So as you know, if I go to the terminal application and I go to the temp folder and I go to the folder hello exec that I've created here, I can type ls to see the hello.c file that I've created now. If I type cat hello.c, I can see what code it contains. So hello.c is not an executable file. It's just a file which contains the C codes. So if I want to make a binary from that, I should compile it. And I can type make hello, and the compilation gets done. And if I type ls now, I see a hello in red. This is actually an executable file. If I type ls-l, you can see that this hello is actually executable in the permissions. So I can run hello by typing ./hello, and if I hit return, it says hello. So what happened? Hello is an executable file which is compiled from another file. But what is important here is that this is the main and the final executable file which we have now. And this hello file is completely independent from hello.c file now. It contains exactly the binaries which is responsible for showing hello on the terminal for me. And if we say cat hello, you see the thing that it is showing to us is completely weird, because it is actually not a human readable text. It is kind of binary, which is computer readable. And so this is exactly what a binary is. Binary is a kind of file which doesn't contain anything understandable for humans. But let's make another file with scripting. For example, imagine in this folder I want to make another file called hello.sh. And in this file I want to say echo hello. This is exactly the echo hello that we have before, that should be interpreted by bash or zsh before getting executed. So we have to mention the interpreter responsible for that. So I type shebang or shebang, and after that I have to link, or better to say I have to type the location of the bash or zsh in my computer that I want to use it as the interpreter for executing the file. So where is bash on my computer? I can easily find the location of every executable file or command on a computer by typing which command. I type which bash, and it says it is located on /bin/bash. You know where is /bin/bash? It is here. Slash is the root folder. On the root folder we have a bin directory, and in the bin directory, which is actually named because of the binaries, there are different types of binaries or executable files in binaries that we use in shells. And as you see, bash is also contained here. Other things like echo, date, chmod, cat, bash, everything. Every important binaries or commands we use are stored in the bin directory, which is stored in the root folder. So If we want to see where is ZSH, we say which ZSH, it says. If we want to see where is the interpreter for Python, we say which Python 3, it says it is here. So for example, if I want bash to be the interpreter for the script I'm writing now, I should say shebang, and after that /bin/bash. I go to the terminal, I go to the home, temp, and what was the name of the directory? It was hello exec. If I get ls-l, I'll see this file called hello.sh. Actually, if I type cat hello.sh, I can see the things that are contained in the file. They are actually the codes I've written recently, but it is not executable. As you see in the permissions, you don't see any x's. So if I type ./hello.sh, nothing happens. But I can type chmod +x hello.sh to make it executable, and now I can type ./hello.sh, and then it runs. As you see, I can run hello.sh, which is a shell script, and I can also run hello, which is actually a binary. And these are two executable files which we have created now. Let me create another script. I want to type another Python script, for example, hello.py. And what I want to do is I want to print hello. I want to do exactly what we have done with the C binary and the shell script, which is showing the hello word on the monitor. So in Python, it should be typed print hello. And I should mention the header, which is shebang. And then the address of the Python interpreter in my computer, which is which Python 3. That's it. And then I paste it here, I save it, I go to terminal, ls, let me clear it, ls-l, it is not executable now, hello.py. I should make it executable. I can type chmod 755 hello.py, ls-l, it is now executable and it's red, so I can type /hello.py and it says hello. So we have made 3 types of executable files, or 3 executable files. This hello is actually a file which contains direct binaries. Another executable file we've made was hello.sh, which was actually a script file, and we wanted to run it by bash. And the other executable file we've made was hello.py, which was also a script file, but we wanted it to be interpreted by the Python interpreter. So that's enough for this video. I hope it to be useful and interesting, and see you later.